Assalamualaikum and hi everyone. We are group CDCS 2515A and today we will be presenting our case study on the Madanet technologies for the ITT550. So my name is Nur Shaza Shaukina binti Nisrahami and I will be presenting alongside with my group mate which is Aida Shazwani binti Samani, Putri Nuliana binti Maksuri and lastly Aiman bin Jamaluddin. Madana Technologies is a Malaysian-based IT solution and also a managed services company and was founded in 2019 and it also headquartered in the Cyberjaya Selangor. It also specialized in software development, cloud solutions, and IT consulting for the corporate clients across the Southeast Asia. So the company operates from two locations, which is the headquarters, which is contain a four-floor building in the Cyberjaya, housing an IT infrastructure, software development, finance and HR, and also management department. So there's also a branch office in the Subang Jaya, which handling the sales and customer support with about 15 to 20 staff. And this branch depends entirely on its connection back to the HQ to access internal system like the CRM platform, HR portal, and shared file server. Now, we will looking at the issues in the current network design. So, the existing network has a flat design with no VLAN segmentation, and there is also no dedicated firewall, and only a single shared Wi-Fi for both staff and guests. The company also relies on a single ISP, and there's an IP address conflict between the HQ and the branch. Additionally, the site-to-site VPN is been unmanaged, and there's also no centralized monitoring in place. So these are the key issues that our proposed design will address later. Thank you.
Assalamualaikum, my name is Aida Shazwani, and for this part of the presentation, I'll be explaining the proposed network design for Madanet solution. Madanet's network follow a hierarchical design with three layers for distribution and access, which limit broadcast domain and makes the network easy to manage and scale. Within each site is formed a hierarchical stack topology with access on the outside, distribution in the middle, and core at the center. At one level, HQ in Cyberjaya act as the hub since it hosts all the centralized resources, while the Subang Jaya branch act as the spoke. HQ uses a full three-tier design, the core router forward traffic between the distribution and the firewall. Two-layer 3 distribution switches connect to all 4 access switches, so either one can route between all the lanes. If one fails, the IGRP reroute traffic through the other and no floor loses connectivity. The branch with just one floor and two VLANs uses a simpler two-tier design for an access only. For VLANs, each department gets its own broadcast domain like VLAN 10 for IT, 20 for development, 30 for finance and HR, and 40 for management, and etc. For protocol, RFCP prevents switching loops and EIGRP handles routing across both sides, and it is chosen over SPF for its faster convergence and lower overhead, and it is better suited to Madanet's smaller and stable network. Now, moving from logical to physical, this shows how these devices are actually placed within the building. At the HQ, we have a 4-story building with one department per floor. The central server room on the first floor houses the firewall, core router, both distribution switches, and access switch 1, and the servers, keeping critical equipment secure and easy to monitor. While the multi-mode fiber runs vertically as backbone cabling from the server room to each floor's access switch, while the copper cabling connects to end devices like PCs, phone, and printers on each floor. Each floor also has one access point, broadcasting a staff and guest SSID, secured with WPA3 and powered through PoE, so no separate power cabling is needed. For both internet lines, ISPA and ISPB connect straight into the firewall, giving dual ISP redundancy. The branch follow the same logic at a smaller scale: one floor, one firewall, router, switch, and access point connected back to HQ through to a site-to-site IP-site VPN tunnel.
Now, I will explain about the WAN service provider and technology used in Madanet's network design. For the WAN design, Madanet implements a fiberless line as the primary technology. This was chosen because it provides a dedicated bandwidth that is not shared with other subscribers, symmetrical upload, and also download speeds, and comes with a 99.9% service level agreement uptime guarantee, which is critical for Madanet's business continuity. At HQ, a dual ISP setup is implemented. ISPA is a time.com at 1 Gbps, which serves as the primary uplink, and ISPB is a TM at 500 Mbps, which acts as the failover. If ISPA becomes unreachable, the core router automatically reroutes all traffic through ISPB within a second. using keep-alive packet monitoring with no manual intervention required. Once ISPA recovers, traffic is automatically shifted back. For the branch, there is no separate ISP connection. Instead, the branch connects entirely back to HQ through a side-to-side IPsec VPN tunnel, which keeps costs lower while maintaining full connectivity to all HQ internet systems. Now, I will explain about the network security mechanisms implemented in Madanet's proposed network design. So, Madanet implements a multi-layered network security strategy based on the defense in-depth principle, where multiple overlapping security mechanisms are deployed across the network. First is the firewall, which is deployed at both HQ and branch. It uses stateful packet inspection and enforce a default deny policy, meaning that all traffic is blocked unless explicitly permitted by the firewall rules. Second is NIT, which hides Madanet's internal IP addresses from the public internet, ensuring that external parties cannot directly identify or target any internal devices. Third is VLAN segmentation with SCLs. Each department is placed in its own isolated VLAN, and access control lists are enforced at the distribution switch layer. This ensures that even if one department is compromised, attackers cannot move laterally to access resources in other departments. Fourth is the gas VLAN. Visitors connect to VLAN 99 at HQ and VLAN 98 at the branch. They are given internet access only and are completely isolated from all internet systems. The guest access ID is also secured with WPA3 encryption. Finally, the side-to-side IPsec VPN tunnel between the HQ and also the branch use AES-256 encryption with IKE-v2 key exchange. Guest traffic is excluded from the tunnel through a split tunneling. This ensures that visitors cannot access any internal resources through the VPN.
Hi, my name is Binti and I'll be explaining the next part, network management. For network management, Madanet uses the FCAPS framework. That's fault, configuration, accounting, performance, and security management to keep the whole network running smoothly. This is handled by a centralized NMS server sitting at headquarters, which talks to every router, switch, firewall, and access point at both HQ and the branch using SNMP version 3, so all that monitoring traffic stays encrypted and authenticated. The system keeps track of things like device status, bandwidth usage, CPU, and latency, and even the VPN tunnel and WAN links. So if anything goes down, a device fails, tunnel drops, or an ISP link fails, the team gets an alert by email and SMS right away, letting them respond fast instead of waiting for someone to report a problem. Moving on to the cost. For the cost breakdown, we split this into two parts, one-time hardware and recurring ISP subscription. The hardware covers 18 devices like the core routers, firewalls, distribution and access switches, our Wi-Fi 6 access points, and the servers, which all comes down to 121,021 ringgit. But that is just the hardware. If you move on to the ISP side, we are paying a total of 799 ringgit per month for our primary 1 Gbps line from time.com, plus 599 ringgit a month for a 500 Mbps failover line from TM, adding up to 16,776 ringgit for the year. Combined, that puts our total first year investment at 137,797 ringgit. A very cost-effective setup that still keeps redundancy and performance in place. So, to wrap things up, this redesign fixes everything wrong with Madanet's old network. All these problems that we had covered earlier, such as the flat network, no firewall, no backup ISP, are now all addressed. Since their new design hits all 6 technical goals, that being performance, reliability, availability, security, scalability, and manageability. The key pieces making this work are the VLAN segmentations, the dual ISP setup at headquarters, the secured site-to-site VPN, and the centralized NMS server that watches over everything through FCAPS. And cost-wise, we're looking at a total first-year investment of 137,797 ringgit that covers both the hardware and ISP subscriptions, which gives Madanet a network that's not just solving to these problems, but built to scale as they keep growing across Southeast Asia.